So, this is the reaction that we're doing today. And whenever we see a chemical reaction written like this, anything on the left, those are the reactants, and then you'll see an arrow. And then anything on the right, those are the products. Okay, so we are going to be mixing baking soda with vinegar. Baking soda is sodium bicarbonate and vinegar is acetic acid. So those two things are our reactants. Those will be, one will be in a zip-off bag and one you'll bring your cup up here and get. And then our products are going to be carbon dioxide, water, and sodium acetate. So is carbon dioxide a solid, liquid, or gas? Gas, right? So who wrote on their bell ringer that one of the signs of reaction is gas formation? Yeah. So what are some other things that we're going to be looking for so we know this reaction is happening? What else did you put on your bell ringer? Solid formation.
Color change.
Color change.
Energy change.
Energy change. Did anyone put temperature change? Okay, so those are the things you're going to be looking for when you're doing this reaction. And then water and sodium acetate are liquids. So this is the question that we are trying to answer today. Is will the mass increase, decrease, or stay the same after the reaction has taken place? So with your group right now, you're going to work on this first column which says to form your hypothesis, okay? So this is the question that we're answering.
I really think decrease. What about you?
Are you guys?
Yes. When the products are at the very end. So when you're all done, that's what you're going to call mass.
Things that you saw.
If bubbles, yeah, and then the bag starts to expand.
Can you feel it? What's the temperature like? Colder.
It's just
It's not. Look, it's not how.
Let's turn the mix.
She can see the edge of the scale himself.
With a good head.
Shut it.
So 11.3 plus 3.3.
Well, this blanket basket is basically this.
Display it on its side, display it right there, because remember the gas is part of the reactant.
Okay, what about?
Wait, don't touch it. Don't touch it. Leave it like that.
How is your mass comparing?
The mass, it went up actually.
A lot or a little bit?
40. That's 40.9. Added the two masses added together.
Yay! Wait, was I right? No, you were right. Yay! That's good.
No, I'm sorry. Did you weigh this? Yeah. Okay. So what was the weight?
Because the air has mass.
Okay. So did every group get a chance to write their numbers up here? Yes. So let's look at the numbers that everybody got and try and figure out the general trend. Okay? So this first group. So remember that these things, the vinegar and the baking soda, are our reactants. Then these are our products. So remember, we're trying to answer, will the mass increase, decrease, or stay the same as we go from products to reactants? So this group started with 58.7 grams and ended up with 57.5. So did it increase, decrease, or stay the same?
Decrease.
It decreased a little bit, but if it's within 1 gram or about 2 grams, we're going to say that it stayed the same. Okay? So it stayed the same. That just allows for experimental error. This group went from 61 51.3 to 60.1. Stay the same. 58.4 to 57.7. Stay the same. Okay, I think this group forgot to write their final mass. Is it down one?
No, this is one that exploded.
Oh, you're right. I'm sorry. Yes. Theirs exploded, so we don't know. Okay, so this one went from 50.8 to 39. So that one definitely decreased. So this one went from 49.1 to 47.3. So we'll say that it stayed the same because that's only about a 2 gram difference. What about 57.6 to 56.4? Same. What about 56.9 to 56? Same. 56 to 55.3? Same. Okay, so what was the general overall trend? Same. Did the mass stay the same, right? So how many of you actually hypothesized, how many of you thought from the beginning it would stay the same? Okay, good. Good. So I think most people thought that it would increase. I think that's what I saw most people putting. So do you guys want to know why it stayed the same?
Yes.
Okay, so the reason why is because of this thing called the law of conservation of mass. So I think you guys have talked about other laws like the law of conservation of energy and matter, and it's very similar to those, okay? So the law of conservation of mass says that in a chemical reaction, mass can neither be created nor destroyed. So at the bottom of your worksheet where it says, so what is important, this is what you can write there, the law of conservation of mass. And did everybody get a chance to write in the general trend? Okay. So another way that we can say this, is saying that mass can only be converted from one form to another, or we can think of it as the total mass of the reactants must equal the total mass of the products. So let's think about the reaction that we just did. What were our two reactants?
One was gas.
Reactants, so what we started with. Baking soda and vinegar, right? So what does the baking soda look like? It's a white powdered solid, and then the vinegar?
Liquidy.
Clear liquid, right? So each of those have their own unique properties. Well, then we mix them together and a reaction happened. And how did we know that a reaction was happening? Lots of things, right? Bubbles, gas formation. How many of you felt the temperature of the bag? What was it like? Cold, yeah. So temperature change, that's a sign of a reaction. So then we know that our reaction happened, and then we formed our products. What did we say our three products were?
Carbon dioxide, water, and sodium acetate.
Yes, it's on your worksheet. Yes. So carbon dioxide was a gas, right? So did your bags expand?
Yes.
So why were they expanding? Right, because carbon dioxide is a gas, so it was expanding and filling up the bag. And then it also formed water and sodium acetate. So those were the liquids that remained in the bag at the bottom that you saw. Okay? So we know, like we said earlier, that this law was discovered by Antoine Lavoisier in the late 1700s. So some more examples of this law would be that if I cut an apple into several slices, then the mass of those apple slices will be equal to the mass of the whole apple. So that kind of makes sense, right? That's what you would think. There is one thing that picture doesn't really show, though. What is it missing? Yes.
The core of the apple and the seeds.
Right, the core of the apple. So really, it'd be the slices plus the core plus the stem would be the same, right? How many of you guys like chocolate milk? Me too. Okay. So this example would be if you start with 450 grams of milk and you add 15 grams of chocolate milk powder, then you would get 465 grams of chocolate milk. So if we thought of this as a chemical reaction, then these two things would be called what? Reactants or products? Reactants. So reactants are what we start with. And then this would be called what? Products. So what can we say about the mass of the reactants? What's the total mass of the reactant? Right. And then what's the mass of the product? 465. Yes, so they are equal because of the law of conservation of mass. And even though milk has its own properties and the powder has its own properties, then the chocolate milk has its own properties, it's okay that they're all different because the mass has just been converted from one form to another. And then this would be, this is the formation of water. So we start with 2 molecules of hydrogen, we add 1 molecule of oxygen, and we end up with 2 molecules of water. So if I were to add up all of these, the molar masses of all of these, I would get 36.03 grams of reactant. If I were to take the mass of these, it would be 36.03 grams of product. Okay? So show me your thumbs how you're feeling about law of conservation of mass. Okay. Good deal. Alright, so I'm going to do one more thing and then we'll do our exit slips. Okay? So we said that, what was the gas that we formed in our reaction? Carbon dioxide. So can you guys in the back see this little candle? If you can't see, you can come up here. So, I'm going to prove to you that the gas that we did form was carbon dioxide, okay? So I'm going to do the same reaction but in here, not in the zip-off bag. And what's going to happen is the carbon dioxide gas is going to form up here. Well, this flame is using what gas to keep burning? Oxygen. Oxygen. So if the carbon dioxide is sitting on top and I pour it out onto there, then it will push away all the oxygen, and what should happen to the flame? It should go out, right? Okay, so let's see if it really is carbon dioxide. Okay, so it's the same thing that you guys just did. I'm going to let it react a few seconds. Can everybody see the flame? Yes.
So cool.
There's carbon dioxide in the air too.